Hello students. So today I am doing class for class 12 science. The topic is first order derivative. In the last class also we were doing the same topic, that is first order derivative. So this is the continuation class. So exercise 3A, page number 294, each question carries 5 marks. So we were doing question number 11, isn't it? So in the last class we did 11 number 1. So let's do question number 11 number 2. So if y is equal to 2 tan inverse within bracket x minus 2 by root 6 minus within square root 2 plus 4x minus x square, so that dy by dx at x is equal to is 2 by root 6. You have to prove that the value of dy by dx at x is equal to 2 is 2 by root 6. From this given, you have to differentiate. That means you have to get the value for dy by dx. And at x is equal to 2, the value of dy by dx would be 2 by root 6, right? So let's write down the given part. Let's differentiate it, okay? So differentiating both the sides with respect to x. So therefore dy by dx is equal to 2 is constant out here. So you can differentiate it by taking it as tan inverse x. So which function is taken as x? X minus 2 by root 6. So what is the differentiation of tan inverse x? It is 1 by 1 plus x square. You know that. 1 upon 1 plus what is x whole square? X minus 2 by root 6 whole square. Right? Actually it is 1 upon 1 plus x square. But here what is the value for x? X minus 2 by root 6. Again you have to differentiate the term which is assumed as x. That is, you have to differentiate x minus 2 by root 6 again, right? Into, so here 1 by root 6 is constant, you have to write it. So within bracket, what is the differentiation of x? 1 minus, what is the differentiation of 2? It is 0. Then minus, again, you have to get the differentiation of within square root 2 plus 4x minus x square. So how can you get it? It is just like your root over x, isn't it? So you can take it as root over x. So which function is taken as x? 2 plus 4x minus x square, right? So what is the differentiation of root over x? It is 1 by 2 root over 2 plus 4x minus x square into, again you have to differentiate the term which is assumed as x. So in this case, 2 plus 4x minus x square is assumed as x. Now differentiate 2 plus 4x minus x square again. So within bracket, what do we get? What is the differentiation of 2? It is 0. Don't write it. Plus, what is the differentiation of 4x? It is 4 into d by dx of x is 1. Then minus, what is the differentiation of x square? It is 2x. Is that clear now? So now let us write down, or dy by dx is equal to 2 ones are 2 divided by this is 1 plus x minus 2 by root over 6 whole square. Don't simplify it because we have to put the value for x which is equal to 2. Then into this is 1 by root 6 into 1 is 1 by root 6. Alright. Then minus, how much is it? It is 4 minus 2x. This whole divided by this whole divided by 2 root over, it is 2 root over 2 plus 4x minus x square. Is it clear now? So now don't simplify it. Just put the value for x is equal to 2. Now you don't have to simplify this one, okay? You put x is equal to 2 here. So I'm putting x is equal to 2. So putting x is equal to 2. So what do we get? So it is dy by dx is equal to 2 divided by 1 plus 2 minus 2 divided by root 6 whole square into 1 by root 6 into 1 by root 6, right? Minus 4 minus this is 2 into 2 whole divided by, in the denominator you write 2 root over 2 plus 4 into 2 minus 2 whole square. Is that clear? So now let us simplify it again. You can simplify it further. So or dy by dx is equal to 2 divided by 1 plus this 2 gets cancels. So it is 0 by root 6 is always 0, 0. Root square is 0 into 1 by root 6 minus this is also 4 minus 4 is 0. 0 divided by number is always that is 0. Or you can simplify it further. 2 root over this is 2 plus 8 10 minus 4. That is 0 divided by number is always 0. So or what is dy by dx now? So dy by dx is equal to 2 1s are 2 divided by this is 1 only. 1 into root 6 is root 6. 0 divided by any number is always 0. So what is the answer? It is 2 by root over 6. So we have proved it. Okay. So the value for dy by dx at x is equal to 2 is 2 by root 6. Okay. So we'll do the next question now. So now we'll do the next question, that is question number 12. So if f of x, that is function of x, is given as a plus x upon 1 plus x whole to the power a plus 1 plus 2x, you have to prove that f dash of 0 is equal to a to the power a plus 1 within third bracket 2 log a plus 1 minus a square whole divided by a. Okay. So this is the given part. So you have to differentiate the given part first. You find out f dash of x and then you put x is equal to 0. To prove this, LHS is equal to RHS. Okay. So this is the given here. That is f of x is equal to within bracket a plus x upon 1 plus x whole to the power a plus 1 plus 2x, right? Now this is the base, this is the power. So this base is the variable, this power is also the variable because they contain x, isn't it? So now in this case you cannot differentiate it directly because both the base and the powers are the variables, that is x. So in this case you have to take log on both the sides so that you can take this a plus 1 plus 2x in the front of this expression. Okay. So now taking log on both the sides, taking log on both the sides, taking log on both the sides. So what do we get taking log on both the sides? What do we get? It is log f of x is equal to log of a plus x divided by 1 plus x whole to the power a plus 1 plus 2x. Okay. Now this power becomes the coefficient because of this log. So there is property of logarithm, isn't it? So because of this log, this power becomes a coefficient. So or this is log f of x is equal to a plus 1 plus 2x into log of a plus x divided by 1 plus x. Is that clear now? So now let us use the properties of logarithm here also. So if you take the properties of logarithm here and if you differentiate it, it will be easier for you to simplify. Okay. So now this is in the form log of a by b. What is log of a by b? It is log a minus log b, right? So or this is log f of x is equal to a plus 1 plus 2x, then within second bracket. This is your log of a by b. That is log a minus log b, isn't it? So it is log of a plus x minus log of 1 plus x, right? So this is the simplification of this log. That is log of a by b is equal to log a minus log b. Okay. So now you can differentiate both the sides with respect to x. And on the right hand side you can use UV rule. Suppose a plus 1 plus 2x is u and within second bracket all this expression is that is v. So we can use the UV rule or product rule out here. So let's do it now. Differentiating both the sides with respect to x. Okay. So therefore, what is the differentiation of log of f of x with respect to x? First of all, it is in the form log x. So it is 1 by f of x into again differentiate f of x with respect to x. That is f dash of x. is equal to. Now we can use UV rule here. So what is the differentiation of this part? What is the differentiation of the first function? A plus 1. 0 plus 2x is 2. Then keep b as it is. That is within second bracket. This is log of a plus x minus log of 1 plus x, right? It is log of 1 plus x, okay? Plus. Then write down plus sign, okay? Now keep u as it is. That is a plus 1 plus 2x. A plus 1 plus 2x is kept as it is. Now within second bracket, now we have to differentiate the first function within second bracket. That is, what is the differentiation of log of a plus x? That is also log x form. So it is 1 upon x. But here it is 1 upon a plus x. Again differentiate a plus x with respect to x. That is always 1. Because for a it is 0 plus for x it is 1 always. So 0 plus 1 is 1. So minus. Then differentiate log of 1 plus x. What is the differentiation of log of 1 plus x? It is again 1 upon 1 plus x. Again it is 1 upon 1 plus x. Again differentiate 1 plus x with respect to x. That is always 1. Right? Into 1. So we get 1 upon 1 plus x. So here second bracket is closed. Is that clear now? So now next, let us simplify this right hand side again. So this is f dash of x divided by f of x is equal to twice into, again you can write here log a minus log b. Again use the formula log of a by b. So it is log of a plus x divided by 1 plus x. And keep the second term as it is, okay? Don't simplify it. So plus a plus 1 plus 2x, and within bracket here we have 1 upon a plus x minus 1 upon 1 plus x. Is that clear? So next, what will you do? Now we have to get only the value for f dash of x, so cross multiply. So or f dash of x is equal to f of x, and within third bracket, write down all these terms. 2 log of a plus x divided by 1 plus x plus a plus 1 plus 2x, right? And within bracket, what do we get? It is 1 upon a plus x minus 1 upon 1 plus x. So is that clear now? So again you have to put the value for f of x, okay? So what was the value for f of x? Actually it is the given function, isn't it? What is the value for f of x? It is, again you have to write a plus x divided by 1 plus x whole to the power a plus 1 plus 2x. Let us write it here. Or f dash of x is equal to, what is f of x? It is a plus x divided by 1 plus x whole to the power x, right? Oh, not whole to the power x, sorry. It should be a plus x upon 1 plus x whole to the power a plus 1 plus 2x. A plus 1 plus 2x. So within the bracket, write down all this expression again. 2 log of a plus x upon 1 plus x, bracket close, plus a plus 1 plus 2x within bracket 1 upon a plus x, then minus 1 upon 1 plus x. So here third bracket is closed. So within third bracket the expression remains same, okay? So now actually you have to get the value for f dash of 0. So how can we get f dash of 0? By putting x is equal to 0. So let us put x is equal to 0. So right now putting x is equal to 0. So putting x is equal to 0. So what do we get? This is f dash of 0 is equal to a plus 0 divided by 1 plus 0 whole to the power what? A plus 1 only, because 2 into 0 is 0. So within third bracket, what do we get? 2 log of, this is a plus 0 divided by 1 plus 0, that is a only, okay? Plus, within bracket a plus 1 only, because 2 into 0 is 0, right? And within bracket it is 1 upon a plus 0 is a, because x here is 0, minus 1 upon 1. First bracket closed, third bracket is also closed. Now again you have to simplify it, or f dash of 0 is equal to a by 1 is always a, so it is a to the power a plus 1, right? And within third bracket it is 2 log a plus this is a plus 1, and within bracket what's the LCM? A and 1 LCM is a. So this LCM is divided by a. A1s are a, that means 1, 1s are 1 minus this is A1s are a. So here third bracket is closed. So next, what do we get now? Or f dash of 0 is equal to a to the power a plus 1 within third bracket. It is 2 log a plus. Now here you can use a plus b into a minus b form. You can write it as 1 plus a, isn't it? A plus 1, 1 plus a are same expression. So you can write here 1 plus a into 1 minus a is a plus b into a minus b. That is your a square minus b square. So it is 1 minus a square divided by a. That is third bracket is closed. So I think it's proved, isn't it? That is a to the power a plus 1 within the bracket 2 log a plus 1 minus a square divided by a. Proved. Okay. So this is very important question. So you can practice it at home. Okay. So you can copy it. So now we'll do the next question, that is question number 13. If f of x, function of x is equal to a plus x upon b plus x whole to the power x plus cos x, find f dash of 0. Now in this case, for the first function a plus x upon b plus x whole to the power x, we need log here, because this a plus x upon b plus x is the base and this x is the power. Both base and the power contain the variable x, so you cannot directly differentiate it. Okay, you have to take log. But for cos x we don't need log here. For cos x we don't need log out here. Okay, but there is plus sign here, so you cannot take log on both the sides here if there is plus sign in between these two terms, right? So in this case you can use u plus v method as we have done in the previous problems in the last online class, isn't it? So let us write down the given part. So f of x is equal to a plus x upon b plus x whole to the power x plus cos x. Now in this case you cannot take log on both the sides directly. Let us assume the first term, that is a plus x upon b plus x whole to the power x as u and cos x as v. Okay, or you can keep it as it is cos x. Okay, so or f of x is equal to, suppose this is u plus v, right? So let us differentiate it. This function is taken as u and this second function is taken as v. So write down differentiating both the sides with respect to x. Okay, so therefore what is the differentiation of f of x? That is f dash of x is equal to differentiation of u with respect to x, du by dx, plus this is dv upon dx. Okay, so now you have to find out the value of both du by dx as well as dv by dx. So let us mark it number 1, and you have to put those values of du by dx and dv by dx in number 1. Okay, so let u is equal to a plus x by b plus x whole to the power x, isn't it? That is the value for u. So we have assumed a plus x divided by b plus x whole to the power x as u. So u is equal to a plus x divided by b plus x whole to the power x. Now if the base and the powers are the variables, you cannot differentiate it directly. You have to take log on both the sides so that the power becomes a coefficient. Okay, so I am taking log on both the sides. So taking log on both the sides. So taking log on both the sides. Okay, so if you take log on the left hand side, you should take log on the right hand side also, right? So this is log u. So log u is equal to log of a plus x divided by b plus x whole to the power x. Okay, now this power x becomes the coefficient, or log u is equal to x log of a plus x divided by b plus x, right? So now again you can use the properties of logarithm on the right hand side, because this log of a by b form is there. So you know log of a by b, isn't it? That is your log a minus log b. So or this is log u is equal to x. So within second bracket. Now this is your log of a by b. So what can you write here? Log a minus log b. That is log of a plus x minus log of b plus x. So here second bracket is closed. Is that clear now? So now again you can use UV rule for differentiation. Now you can differentiate both the sides with respect to x, isn't it? So after writing the properties of logarithm here, you can differentiate both the sides, because it will be easier for you to differentiate after you apply the properties of logarithm out here. Okay? So now differentiate both the sides with respect to x. Okay? So differentiating both the sides with respect to x. Okay? So what is the differentiation of log u with respect to x? It is 1 upon u into du by dx, which is equal to, which rule is used now? Again UV rule. X is u and within second bracket it is v. Okay? So you know UV rule, right? So what is the differentiation of x with respect to x? That is 1. You don't have to write 1. So keep the v as it is. That is log of a plus x minus log of b plus x. So here second bracket is closed. Then plus x is kept as it is, as there is no space there. So I am writing it down here. Okay? Plus now x is kept as it is. Now within second bracket, again differentiate log of a plus x. How will you differentiate it? You should take it as log x. What is the differentiation of log x? 1 upon a plus x into 1. How did you get that one? Again differentiate a plus x with respect to x. That is always 1. For a it is 0 and plus x is, it is 1. Okay? Minus again, what is the differentiation of log of b plus x? It is 1 by b plus x into, again it is 1. How did you get that one again? Differentiation of b plus x, right? So here second bracket is closed. So I think you have understood it. Okay? Now let us simplify it further. Or 1 upon u into du by dx is equal to, within second bracket, again it is log a minus log b. What is log a minus log b? Log of a by b, that is a plus x upon b plus x. That is your log of a by b. Keep the second term as it is, that is x. Don't simplify it. So keep it as it is, x into within bracket 1 upon a plus x minus 1 upon b plus x. So is that clear now? So or du by dx is equal to u within third bracket log of a plus x divided by b plus x, then plus x within second bracket 1 upon a plus x minus 1 upon, it is b plus x, and third bracket is closed here, right? So now you have to put the value for u. Actually what was u? This first term was u, isn't it? Because we had assumed this term as u plus and cos x as v. That is u plus v was there, right? So now or du by dx is equal to, what was the value for u? It is a plus x upon b plus x whole to the power x, right? So that is the value for u, and within third bracket remains same. That is log of, write down, a plus x upon b plus x plus, next, plus x within second bracket 1 upon a plus x minus 1 upon b plus x, second bracket closed, then third bracket is also closed. So this is your value for du by dx. So now what is to be found out? You have to find out now dv by dx, isn't it? What was v actually? It is cos x. So again, let v is equal to cos x. So we can directly differentiate it. We don't need log out here. Okay. So differentiating both the sides with respect to x. So what do we get? That is dv by dx is equal to, what is the differentiation of cos x with respect to x? It is minus sin x. So it is minus sin x. Is that clear to all of you? So we have got both the values of du by dx and dv by dx. Okay. Now let us put these values of du by dx and dv by dx in 1. So we had assumed that is f dash of x is equal to du by dx plus dv by dx as 1, isn't it? So if it is not written out there 1, you write it as 1. That is the relation f dash of x is equal to du by dx plus dv by dx. You can check it. So in the previous step we had written du by f dash of x is equal to du by dx plus dv by dx. If it is not written 1, make it dash number 1. Okay. So now write down, putting the values of du by dx and dv by dx in 1, right? So putting the values of du by dx and dv by dx in number 1. So what was number 1 actually? It is f dash of x is equal to du by dx plus dv by dx. Is that clear? So now let us put the value for du by dx. What is it? Or f dash of x is equal to, what was du by dx? It is a plus x by b plus x whole to the power x plus within the, then within third bracket it is log of a plus x divided by b plus x, right? So you can check it in the previous steps. So we had du by dx as a plus x divided by b plus x whole to the power x within third bracket. This is the du by dx part, isn't it? Log of a plus x divided by b plus x plus x within second bracket 1 upon a plus x minus 1 upon b plus x, second bracket closed, third bracket is closed. So we have put the value for du by dx, right? And what was dv by dx? It is minus sin x. So this is minus sin x, right? So this is the value for f dash of x. Okay? So now don't simplify it, because in this case you have to get the value for f dash of 0. So how can we get the value for f dash of 0? You put x is equal to 0. So putting x is equal to 0. Putting x is equal to 0, what do we get? F dash of 0 is equal to, what do we get here? A plus 0 divided by b plus 0. That means a by b. So it is a by b whole to the power 0. And within third bracket, log of this is a by b only. A plus 0 a, b plus 0 b. Plus, now this is 0 within second bracket 1 upon a minus 1 upon b. Second bracket closed, third bracket closed. And then minus sine 0. Then minus sine 0 is there. So you know the value for sine 0, isn't it? What is the value for sine 0? That is 0 always. Okay. So now you can write down the final answer now. So f dash of 0 is equal to, what is a by b whole to the power 0? That is always 1 within third bracket log of a by b plus 0 into any number is always 0. So what is the final answer now? What is the answer for f dash of 0? What is the value of f dash of 0? Which is equal to 1 into log of a by b is, it is log of a by b. So this is the final answer. So if f of x is equal to a plus x upon b plus x whole to the power x plus cos x, find f dash of 0. That is, what is the value for f dash of 0? So f dash of 0 is equal to log of a by b. Okay, is that clear to all of you? So you can copy it. We'll do the next question now. So now we'll do the next question. That is question number 14. If y is equal to tan inverse within third bracket, it is given within square root 1 plus t square plus within square root 1 minus t square whole divided by within square root 1 plus t square minus within square root also 1 minus t square is there. So find the value of dy by dt. So here also you cannot differentiate it directly from given. Okay. So on the right hand side there is tan inverse. In terms of t, the fraction is given. You have to do the trigonometric substitution. So what should you put for t? So let us write down the given here now. So here given is y is equal to tan inverse. So within third bracket it is root over 1 plus t square plus root over 1 minus t square divided by root over 1 plus t square minus root over 1 minus t square. Okay. Now you should do the trigonometric substitution. So you have to do the trigonometric substitution in such a way that you have to simplify both numerator as well as denominator, and you should get it in the form of tan inverse tan theta form, so that you can write only theta, because you know that tan inverse tan theta is always theta. Is that clear? So let us put t square is equal to cos theta. So why are we substituting cos theta for t square? Because you know that 1 plus cos theta. If you put t square is equal to cos theta, what do we get? 1 plus cos theta is equal to, what is the formula? It is 2 cos square theta by 2, right? You should know this formula. And also if you put here cos theta, it will be 1 minus cos theta, and which is 2 sin square theta by 2. You should know this formula, right? So we have done it in class 11, that is in submultiple angle, right? So what is 1 plus cos theta? It is 2 cos square theta by 2. And what is 1 minus cos theta? It is 2 sin square theta by 2. Is that clear now? So let us put t square is equal to cos theta. So let t square is equal to cos theta. So what is the value of theta now? It is cos inverse t square. Okay? So you have to get the value for theta also. Right? So therefore y is equal to, this is tan inverse. Now within the bracket, within square root 1 plus cos theta plus, again within square root it is 1 minus cos theta divided by root over 1 plus cos theta minus root over this is your 1 minus cos theta. Okay. Now we can use the formula, isn't it? So that it will be easier for you to simplify and get differentiation. Okay. So y is equal to, therefore y is equal to tan inverse. Now within third bracket, so within square root, what is 1 plus cos theta? I just wrote it here, isn't it? So what is 1 plus cos theta? It is 2 cos square theta by 2. 2 cos square theta by 2, right? Then plus root over 1 is 1 minus cos theta. It is 2 sin square theta by 2 whole divided by, in the denominator within square root, what is 1 plus cos theta? It is 2 cos square theta by 2 minus, so minus sign is there, root over 2 sin square theta by 2. That is 1 minus cos theta is 2 sin square theta by 2. That is from the submultiple angle. So I think you have understood it. Okay. So or y is equal to tan inverse within third bracket. What is square root of 2 cos square theta by 2? It is root over 2 into cos theta by 2 plus it is root over 2 into sin theta by 2. Okay. Divided by, again within square root 2 cos square theta by 2, what is it? It is root 2 into cos theta by 2 minus again it is root over 2 into sin theta by 2. Root over 2 into sin theta by 2. So here third bracket is closed. Is that clear now? So now next step. So what will you do in the next step? In the numerator root 2 is common. In the denominator also root 2 is common. So you can take it outside. That root 2 will be cancelled. And what do we get? Or y is equal to tan inverse within third bracket, you can write cos theta by 2 plus sine theta by 2 divided by, it is cos theta by 2 minus sine theta by 2. So I think you have understood it. Okay. So now how can we simplify it again? Again you have to simplify it. Okay. So this is not the simplified form now. Now since that is tan inverse, you should convert this fraction in terms of tan. That means if you convert this term into tan, you have to divide sine by cos, isn't it? Sine by cos is tan. So in the numerator and in the denominator, you should divide it by cos theta by 2. Okay. So or y is equal to tan inverse within third bracket. You divide both the numerator and the denominator by cos theta by 2. What do we get? Cos theta by 2 divided by cos theta by 2, that is 1 plus, it is tan theta by 2 divided by, now cos theta by 2 divided by 1, cos theta by 2 divided by cos theta by 2 is 1 minus, this is tan theta by 2, right? So now what will you do now? You know tan A plus tan B divided by 1 minus tan A tan B, that is from compound angle in trigonometry, right? So instead of this 1, you have to write tan pi by 4, you know that, right? So y is equal to tan inverse. So here you can write tan pi by 4 plus tan theta by 2 divided by 1 minus, this is tan pi by 4 and this is your tan theta by 2. Third bracket is closed, right? So what is the formula now in this case? It is tan A plus tan B divided by 1 minus tan A tan B. You know that. What is the formula for tan A plus tan B divided by 1 minus tan A tan B? It is tan of A plus B, right? So let us write it here now. So or y is equal to, this is your tan inverse. So what is the formula you can use here? Tan of A plus B. So tan of, what is A out here? A here is pi by 4 and what is plus B? It is plus theta by 2. So I think you have understood it. Okay. So what is tan inverse tan of pi by 4 plus theta by 2? Y is equal to pi by 4 plus theta by 2. Now you have to put the value for theta. Actually we had assumed, so you can check in the previous steps. So t square was cos theta, isn't it? T square is equal to cos theta. What is the value for theta now? Cos inverse t square, you know that. Or y is equal to pi by 4 plus half. This is cos inverse t square. Right? Now you can differentiate it. Now differentiate both the sides with respect to t so that you can get the value for dy by dt. Now you can easily differentiate it, isn't it? So write down differentiating both the sides with respect to t. So differentiating both the sides with respect to t. Okay? So what do we get? dy by dt is equal to, now for pi by 4 it is 0, you know that. You don't have to write it. Half into, now differentiate cos inverse t square with respect to t. So first of all it is in the form cos inverse t. Which function is taken as t? T square. So what is the differentiation of cos inverse t? It is minus 1 upon root over 1 minus t square. What is t square here? T square whole square into. Now which function was taken as t to differentiate it? T square. Again you have to differentiate that term t square with respect to t. So into, what do we get? What is the differentiation of t square with respect to t? It is 2t. Right? So here you can cancel this, 2 gets cancels. So or dy by dt is equal to minus 1 1 1, 1 into t is t divided by root over 1 minus t to the power 4. So this is the final answer. So this question is very, very important. Okay. So now we'll do the next question. So now we'll do the next question, that is question number 15. So if y is equal to cot inverse, now cot inverse is given and within bracket there is a fraction. So root over 1 plus x minus root over 1 minus x whole divided by root over 1 plus x plus root over 1 minus x. so that dy by dx at x is equal to half is equal to minus 1 upon root 3. So dy by dx third bracket is closed, and here below here it is given x is equal to half. That means you have to get the value for dy by dx when x is equal to half. So first of all you get the value for dy by dx by simplifying this right hand side. So first of all you simplify cot inverse root over 1 plus x minus root over 1 minus x divided by root over 1 plus x plus root over 1 minus x. That means you have to get this cot inverse in the simplified form. So in this case also you have to do the trigonometric substitution. So 1 plus x, 1 minus x, 1 plus x, 1 minus x is there. So you can put x is equal to cos theta here also. Because 1 plus cos theta is 2 cos square theta by 2 and 1 minus cos theta is 2 sin square theta by 2. You know that, isn't it? So let's write down this given. So given y is equal to, let us convert this cot inverse into tan inverse. So how can you convert cot inverse x into tan inverse? You know that in inverse-order function, it is tan inverse 1 upon x. So it is tan inverse. What is 1 upon x here? You have to make it upside down. That is, numerator goes to the denominator and denominator to the numerator. That is root over 1 plus x plus root over 1 minus x divided by root over 1 plus x minus root over 1 minus x. Is that clear? So now let's do the trigonometric substitution to simplify it so that it will be easier for you to differentiate. Okay? So let x is equal to what? Cos theta. And what is the value for theta here? It is cos inverse x. Okay? So therefore y is equal to tan inverse within bracket root over, this is your 1 plus cos theta plus root over 1 minus cos theta divided by root over 1 plus cos theta minus root over 1 minus cos theta. Okay? So this is the expression, right? And now what is the formula for 1 plus cos theta? You know that. What is 1 plus cos theta? It is 2 cos square theta by 2. And what's about 1 minus cos theta? It is 2 sin square theta by 2. Is that clear? So let's write down the formula here. Y is equal to tan inverse within bracket. Now within square root, what is 1 plus cos theta? It is 2 cos square theta by 2 plus within square root, what is 1 minus cos theta? It is 2 sin square theta by 2, right? Divided by. So in the denominator, root over what is 1 plus cos theta? It is root over, again it is 2 cos square theta by 2 minus root over, what is 1 minus cos theta? It is 2 sin square theta by 2. It is 2 sin square theta by 2. Is that clear? So let's simplify it again. Now you can simplify it. Or y is equal to tan inverse within bracket. Now get the square root of 2 cos square theta by 2. What is it? It is root over 2 cos theta by 2 plus root over 2 into sin theta by 2 divided by, what is square root of 2 cos square theta by 2? It is root 2 into cos theta by 2 minus root 2 into sin theta by 2. Bracket is closed. Okay? Now, how will you simplify it? In the numerator root 2 is common, in the denominator also root 2 common. So root 2 gets cancelled. So what do we get now? Or y is equal to tan inverse within bracket cos theta by 2 plus sin theta by 2 divided by what do we get? It is cos theta by 2 minus sin theta by 2. Is that clear? So now, you can convert, now you can convert them into tan theta by 2 form, isn't it? Since outside bracket there is tan inverse, this is in terms of tan. So you have to convert this fraction in terms of tan also. That means you have to divide both numerator and the denominator by cos theta by 2. So what do we get? Y is equal to tan inverse within bracket. Now divide by cos theta by 2, what do we get? 1 plus tan theta by 2 divided by 1 minus this is tan theta by 2. Now what will you do? So you can convert it into the form of what? You can convert it into the form of what? Tan inverse, this is 1, isn't it? This is 1. Instead of 1 you can write tan pi by 4, right? Or y is equal to, this is your tan inverse, within bracket instead of 1 you write tan pi by 4 plus tan theta by 2 divided by 1 minus, this is your tan pi by 4 and this is your tan theta by 2. Is that clear? So this is the form tan A plus tan B divided by 1 minus tan A tan B. You did it in class 11, isn't it? In trigonometry, in compound angle, there is a formula tan A plus tan B divided by 1 minus tan A tan B, which is equal to tan of A plus B. Okay? So, or y is equal to, this is your tan inverse. Now tan of what is A plus B out here? It is pi by 4 plus theta by 2. Clear? That is tan of A plus B. B is theta by 2 here. Or y is equal to, what is tan inverse tan pi by 4 plus theta by 2? That is only the angle, that is pi by 4 plus theta by 2. So that is the simplified value of y. Now you put the value for theta. Actually, what was theta here? Actually, we had assumed x is equal to cos theta, isn't it? This x was assumed as cos theta. So what is the value for theta here? Cos inverse x, right? So therefore y is equal to pi by 4 plus, you write half first, then theta. What is theta here? It is cos inverse x. Is that clear to all of you? Now you can differentiate it easily, isn't it? So this is the simplified form of the value of y. So you can easily differentiate it. So differentiating both the sides with respect to x. Okay, so therefore it is dy by dx is equal to, for pi by 4 it is 0 plus half is constant, half is with the variable, so half remains same, into what is the differentiation of cos inverse x? There is direct formula, minus 1 upon root over 1 minus x square. Is that clear? But in this case, dy by dx is there within third bracket, and below here there is x is equal to half. That means you have to get the value for dy by dx when x is equal to half. So putting x is equal to half now. So putting x is equal to half, what do we get now? Yes, tell me, what do we get? Putting x is equal to half, therefore dy by dx is equal, that is your 0. So plus and minus, this plus and minus is minus half into 1 upon, so wherever there is x, you put x is equal to half. So within square root 1 minus, what is the value for x here? It is half whole square, right? So let us simplify it. Or dy by dx is equal to minus half into 1 upon root over 1 minus 1/4. Is that clear? So now let us simplify it further. Or dy by dx is equal to minus half into 1 upon within square root. You can simplify it. 4 ones are 4 minus 1, that is 3 by 4, right? So what is square root of 3 by 4 now? Yes, tell me, what is dy by dx? So dy by dx is equal to minus half into, this is 1 upon, so within square root 3 by 4, what is it? What is square root of 3 by 4? It is root 3 by 2. So here 2 gets cancels. So what do we get now? Or dy by dx is equal to minus 1 upon root 3. So it is proved. So we got the answer, isn't it? That is, what is the value for dy by dx at x is equal to half? It is minus 1 upon root 3. That is proved. Is that clear to all of you? So this was this for today. Okay. So you revise all the problems that we did today, and in the next class we'll do more problems. Okay.